You can take the smartest model on the planet and make it measurably dumber by doing one thing, giving it more to read, and this happens to everyone who works with AI agents, whether they've noticed or not. You start a session and the model is brilliant. An hour in, that same model is repeating work it already finished, quoting files that don't exist, and forgetting things you told it 3 times. Same model, same tools, same task. So what changed? Most people blame the model, and that's the wrong suspect. The thing that changed is what the model was reading. Because a model's attention is a budget, and every word you pile into its window spends from it. By the end of this video, you will know exactly how that works and the 4 moves that fix it. A while back, I made a video sorting the AI buzzwords into a ladder, and one of the rungs was context engineering. I gave it about 30 seconds because honestly, I thought it was the obvious one. I was wrong, and this video is me paying that debt properly. So here is the question I'm going to answer by the end. Why does the same model get dumber the longer it works? And what do the people who fix this actually do differently? The answer starts with a fact about these models that everyone hears once, nods at, and never actually sits with. The fact is that the model is stateless. Every request, it wakes up with total amnesia, reads one package, answers, and forgets all of it. That package is the context window, and it's everything the model will ever know. Even a chat conversation is a magic trick. Every time you hit send, the software quietly resends the entire conversation so far, plus your new message, as one fresh package. The model isn't remembering the conversation, it's rereading it from the top every single turn. Now let me show you the part that shocked me the first time I actually looked. This is a real turn from a coding agent, cut open like a core sample. At the top sits a system prompt, the standing orders that tell the model how to behave. Then every tool it can use, each one described in full every single turn. Then the whole conversation so far, and the contents of every file it opened. And all the way down here, this thin sliver, that's the message I actually typed. This one turn was tens of thousands of tokens before I said a word. My line was around 2% of what the model read. When you talk to an agent, you aren't writing its input. You are contributing a footnote to a document you've never seen. So hold on to the principle because the whole video hangs off it. Whatever is in the window is the model's entire world. Whatever is not in the window does not exist at all. The model never remembers, it only reads, and once that sinks in, the obvious fix seems to be make the window huge and put everything in it. The entire industry made that bet, and it went wrong in the most interesting way possible. For a few years, context windows were the arms race. They grew from a few thousand tokens all the way past a million. A million tokens is roughly a small stack of books handed over in one go. And the sales pitch wrote itself: drop your whole code base in, drop every document in, let the model sort it out. The proof was a benchmark with a great name, the needle-in-a-haystack test. Hide one sentence inside a mountain of text, ask the model to find it, and the new models passed with near perfect scores. But finding one fact is just retrieval. Real work is reasoning, holding scattered pieces together and connecting them, and that's a completely different muscle. Then, researchers measured what happens on that second kind of task as the window fills, and the result got a name that stuck: context rot. As you add tokens, answer quality doesn't hold steady, and it doesn't fail loudly either. It quietly slides downhill on the same model with the same question buried inside. Here is the picture that finally made it click for me. The model's attention is like a lamp over a desk. Put 3 cards on the desk, and each one sits in bright light. Pile on 300, and that same lamp has to spread across all of them, so every card gets dimmer. Every token you add is spending from the same attention budget, whether it deserves the light or not. A million token window does not come with a million tokens of attention. Which finally explains the agent from the start of this video. An agent working for an hour drags its whole history behind it, every file it opened, every dead and every old version of the truth. The deleted file was still in its window, sitting in the light, looking exactly as real as everything else. The model didn't run out of memory. It ran out of attention. So if stuffing the window makes things worse and starving it makes the model clueless, somebody has to decide deliberately what goes in. That decision turned out to be a whole discipline, and in the middle of 2025, it finally got its name. A couple of well-known engineers pushed a phrase for it, and it took off because everyone instantly recognized the problem. Context engineering. One definition stuck, and I think it's the best one. The delicate art and science of filling the context window with just the right information for the next step. If you saw my ladder video, this is rung 2, and now you can see why it earned a rung of its own. Prompt engineering was about the words in one message. Context engineering is about the whole window. The job moved from writing a better question to deciding what the model even gets to see. And here is the twist that separates the people who are good at this from everyone else. You'd think the job is gathering, finding more relevant stuff to shovel in. It's the opposite. Because every token spends attention, the real skill is subtraction, deciding what to leave out. A good context engineer looks at the window like a crowded desk and asks one question about every card on it. Does this help answer the very next question, or is it just dimming the light? And in practice, most people doing this well are making some mix of the same 4 moves, so let me show you all 4. Select, compress, write, isolate. Each move exists to fix one specific failure, so let's take them in order. Move 1 is select, and it fixes the forklift problem. The lazy version of context is dumping everything you have into the window and letting the model dig. You now know why that fails. The pile dims the lamp. Selecting means fetching just the pieces that matter for this one step, and nothing else. I keep a personal wiki that an AI maintains for me, hundreds of small pages about my projects and my life. When I ask it a question, it never reads the whole wiki. It reads one small index page first, like a table of contents, decides which 2 or 3 pages actually matter, and pulls only those under the lamp. That's the entire pattern, an index that's cheap to read, pointing at details that get fetched only when needed. Move 2 is compress, and it fixes the problem of things that grow. A long session's history gets bigger every turn, and remember, all of it gets reread every time. So at some point, you squeeze it, you replace the full transcript with a summary that keeps the decisions and drops the noise. If you use a coding agent, you watch this happen, that moment where it says it's compacting the conversation. One warning though, compression is lossy on purpose. A summary keeps what the summarizer thought mattered, and the detail you need tomorrow might not have made the cut. Which is exactly why the next move exists. Move 3 is right, and it fixes the amnesia itself. If the window is temporary, then anything that must survive has to live outside it, in files, in notes, in a scratch pad the agent keeps. So the good agents write things down, mid-task, decisions made, work finished, what broke and why. Next session, the window starts empty, and the first thing that flows back in is those notes. And catch what that means, because it's the reframe this whole video is built on. When an agent seems to remember you, what actually happened is that it wrote a note and something showed it that note again. Nothing is ever remembered. Things are written down and then they reread. Move 4 is isolate, and it fixes the pollution problem. Some jobs are messy by nature. Searching a huge codebase, reading 20 documents, trying 5 approaches until one works. Do that in your main window, and the mess moves in permanently, every dead end still sitting in the light an hour later. So you hand the messy job to a separate agent with its own clean window. It burns its window on the search, and it sends back one thing, the conclusion. Your main window keeps the answer, not the 80 files that produced it. So that's the whole toolbox. Select what enters, compress what grows, write what must survive, isolate what pollutes. Every memory feature, every retrieval pipeline, every sub-agent pattern you'll ever meet is some mix of these 4 moves. Now let me give you the exercise that makes this real, because it takes about 20 minutes and it changes how you use these tools. Here is the exercise. I call it the context audit. Take the AI tool you use the most and get your hands on the raw package it actually sends to the model. In most coding agents, that's a verbose flag or a debug log, and if you're calling the API directly, just log the full request body before it goes out. Either way, you want the raw package, not the pretty chat view. Take one real turn from your real work and read the whole thing, top to bottom. I promise the first read will shock you. It did me. You'll find whole files nobody asked for, tool results from an hour ago, instructions repeated 3 times, and somewhere in the middle, your tiny 2%. Then interrogate every block with the desk question. What question does this help answer right now on the next turn? If a block has no answer, it isn't neutral filler, it's spending your attention budget and it should go. And if you want the habit version instead of the one-off, it's this. Keep the standing instructions you give your tools short, current, and ruthless, like a desk you clean, not an attic you fill. Keep an index that points to detail instead of pasting the detail everywhere. And have the agent write down what happened, so the next session can select it back instead of rediscovering it. Do that, and you are already doing by hand what the best teams in the industry are building machinery for. Before I close the loop on the opening question, sit with the strange upside of all this for a second. Everything an AI seems to know is lying right there in the window where you can read it. Its memory is a note someone chose to show it again. Its knowledge of your project is a file someone chose to include. So when it acts smart, you can see exactly why, and when it acts dumb, you can usually point at the very line that did it. The window isn't just the model's whole world, it's the one part of this strange technology you can open, read, and change. So back to the question from the start. Why does the same model get dumber the longer it works? Because the model never remembers, it only reads, and nobody was curating what it read. The window filled with yesterday's noise, the lamp spread thin, and the sliver that mattered got lost in the pile. And the people who fix it aren't doing prompt wording or model magic. They select what enters, compress what grows, write what must survive, and isolate what pollutes. It's editorial work done on the model's entire world, one turn at a time. And if you are climbing the ladder with me, here is where this connects forward. Once you are curating the window by hand, the obvious next thought is, why am I doing this manually? The software that packs the window for you, every turn, automatically, that's the harness rung 3, and I've made that whole video too. But whatever tools you end up using, the discipline underneath doesn't change. The model never remembers, it only reads. So decide what it reads, and you've decided how smart it gets to be.